This episode is brought to you by Shopify. Upgrade your business with Shopify, home of the #1 checkout on the planet. Shop Pay boosts conversions up to 50%, meaning fewer carts going abandoned and more sales going cha-ching. So if you're into growing your business, get a commerce platform that's ready to sell wherever your customers are. Visit shopify.com to upgrade your selling today.
Hello and welcome to Carbon Removal Newsroom. I'm Ross Kenyon. Thanks for joining us. Today I have with us Eric Matzner, co-founder of Project Vesta. Eric, thanks for joining us. What is Project Vesta?
Hi, Ross. Thanks for having me. Project Vesta is a project to help remove CO2 from the atmosphere by accelerating the weathering of a special type of rock on beaches.
Wow, that was very succinct. Yes, that is my understanding from reviewing your materials as well. A colleague of mine, Paul Gamble, nudged me the other day and said, hey, this nonprofit just left stealth mode. You should check this out. So what have you been working on and how exactly does your project work?
Well, our project works in the same method that Earth works to remove CO2 in the carbon cycle. So if you haven't studied geology or carbon cycle recently, basically volcanoes put up CO2, goes in the air, interacts with water, becomes acidic, rains down on rocks. Those rocks that are made from volcanic materials then run into the ocean and become materials for corals, calcium carbonate that is used in the shells. Those shells then turn into corals and limestone. That limestone eventually gets subducted down under the sea, and in a few million years, it could come up again as a volcano. So that means there is a process for Earth to remove CO2. And so we know that the last 3 ice ages have been caused by exposure and weathering of volcanic or ultramafic rock around the equator. And so we're looking to harness Earth's natural process to make it better, faster, and more optimal, because we can choose a location and the right type of rock, which Earth cannot.
Yes, and in reviewing your materials, I saw that we have to mine this rock, this olivine, and then place it strategically in places that would allow it to weather correctly in the right way, to be moved around in the right way, to absorb the greatest amount of carbon dioxide. Is that correct?
That is correct. Fortunately, with the mining, the rock itself is the most abundant mineral on Earth. It makes up over 50% of the upper mantle. So we're talking about a rock called Olivine. And there's a couple different types. We're looking at one that's magnesium silicate, which is also known as forsterite. And there's these formations called dunite. Sorry for all these geological terms. I had to learn all of them in this.
No, it's okay. It makes us feel smart. It's good to hear.
Yes. Well, I don't mean to use big words. That's just, these are the words. So then there's a formation called dunite that's 90% pure olivine. And so the idea is there's reserves on every continent, every country, well, not every country, but every continent and near every country. And so the idea is we could take that rock and then put it onto beaches, because part of the problem in the speed of the weathering is the silicate coating builds up on the outside, and so you need to tumble the rocks, and so to break that coating off, and you can accelerate it by a magnitude, so like around 1,000 times the natural weathering rate. And so we put it on these energetic shelf seas where there's a lot of room for tumbling and bed shear forces underwater, whatever, where they can drag the rock and break this coating off and cause collisions that break into even smaller particles. We can then make it so that these things weather in a year or 2 or 5 maximum realistically, and take the CO2 out. So for each ton, this is amazing math here that really got me hooked, is each 1 ton of the rock, olivine, removes 1.25 tons of CO2 from the air or the water that it's dissolved in.
Is there a range? Is that one of the bounds? Is that just the average?
No, I mean, there's something called a dynamic equilibrium. So we basically know that this rock will weather completely in X amount of time. And so basically, because there's unlimited CO2 entering into the ocean, essentially, in this type of reaction, the olivine will continue to weather until it's gone. And that's just stoichiochemistry kind of stuff like that, where it is a reaction that will occur. If the surface of the olivine is exposed, it will weather. And there's even crazier things or wilder things that aren't even fully calculated in any lab experiments, which is things like lugworms in the shallow water can eat the grains and weather it 1,000 times extra. So we have all these, and there's bacteria on the land that break it down further and release different acids that reward the plant for breaking, fungi reward plant for breaking it down. There's all sorts of symbiotic relationships with these nutrients and nature and water, and in this process of removing CO2 and putting it into marine animal shells.
Wow, that's exciting. I've been hearing about Olivine for a long time. Wait, is it Olivine or Olivine? Are you saying both?
I may be saying both because I read it and then I've heard other people say different ways. So I think I say it weird. I say Olivine, but I believe it might be Olivine.
Okay, I'm gonna go with Olivine. It sounds a little bit like a shampoo, but that's okay. Someone's gonna correct me at a conference, I'm sure. But I'm sticking with Olivine for now.
Yeah. Well, I think you're fair to use it either way. That happens sometimes.
Yeah, it's definitely possible. Well, what happens now with your group? So is there a way that people can pay to have this done? Are you in a testing phase? What's happening?
Yeah, great question. So we have a multi-front approach to this problem and process because we have the actual physical idea of the beaches to weather. But part of what we're doing here is making a movement, getting people involved, changing the conversation from, okay, let's cut our emissions to, okay, let's cut our emissions, but stop just waiting. Let's start taking them out. Let's attack this equation from the other side, which is something I think other people are fearful to discuss because they're worried that it might stop people from cutting their emissions, which I want to be clear. Cut your damn emissions, all right? But we also need to remove the emissions that the U.S. is responsible since before we were in a country, North America, we've put out 400 billion tons. We are responsible in the U.S. for more CO2 in the atmosphere than India, China, and other countries. Basically, we are terribly ahead in this worst race ever. So we need to get ahead in this race to remove it and to get this carbon out. And so what we're doing is we want to start a movement. And part of that movement is that we're going to use jewelry made with the beautiful green olivine stone. If you don't know what olivine looks like, it's the gemstone version is the August birthstone. It's called peridot. But instead of birthstones, we want to make earthstones. So we want everyone to be wearing olivine necklaces, jewelry, bracelets. And then when you pay us, so olivine is about $25 a ton. And so the average US person's CO2 output they're responsible for is about 18 tons. So around $300, we can dump 15 or more tons of olivine on the beach if you buy that necklace. So we're not at that stage yet because we don't have beaches, but we're selling a smaller necklace called the Grain of Hope right now at our launch, which is a single grain of olivine stuck in a sand time vial on a necklace. So it's like, we are here, but we have a way to stop time from running out, or at least give us more time to remove the CO2. And that's why it's called the Grain of Hope.
I see. And I have also seen pictures. I don't know if these are simulated or if this has been done somewhere, but the beaches are now green.
So that's not simulated. That's a natural olivine beach. That one is in Hawaii. That's on our website is Mahana Beach or Papakolea. And that's a volcano opened up and just dumped all its olivine on the beach there. And so we know these beaches are safe. There's another one in the Galapagos. There's about 3 or 4 other known ones around the world. That one in Hawaii is particularly accessible and particularly beautiful.
One of the questions I have is, I believe beaches are public property typically in the United States. There must be private beaches too, but how do property rights interact with this solution?
So you'd be surprised actually how many beaches there are. Like there's very profitable beaches in terms of tourism and other things like that. But many beaches around the world are not accessible by even roads. And many of them have rocks and don't have desirable sand, or they may have seaweed. There may be all these things that make a beach undesirable. So we're actually found that out, that it's really not that difficult to find a beach. Although if you're listening and you have a beach, let us know. But we're trying to find this trifecta of like being less than 300 kilometers away from an olivine mine, having the infrastructure like railway or an easy access port to move it so we can lower the CO2 output of the transport, which is around 4% loss. So, for every 1.25 tons of CO2, we're losing like the 0.05 in the transport, mining, and milling. And so the idea is to minimize those costs. Like some of our early things will be to take like piles called tailing piles, waste piles of olivine already sitting on the sites of mines, already dug up. So we're not calculating that we have that CO2. So only the transport, not even just the mining. But the idea is then to put it onto beaches that are maybe either not desirable for economic reasons and whatnot, but also ones that are potentially privately owned, potentially government owned, potentially ones that would not mess with anyone or any animals or any other sort of right of way that's necessary. And so the math, which is also amazing, is so it's 2% of the shelf seas of the whole world. So it's not that much. On a realistic scale, it's a volume of 7 kilometers cubed, or approximately less than 1 meter per person of olivine per year to offset all of humanity's CO2 for that year.
That's a big number. That's
It's a number.
No,
I would say, first of all, we're not starting right there. We're going to start with the beach, but don't be overwhelmed by the top line number, because when you actually look at how much coal we mine and how much oil equivalents we mine, it's significantly more. So I don't like to say that, we can't go to the same ends that we go to like cause these problems to fix them. Like, you have to tell me we should at least go there. And so we're already mining more than this. So that's not a reason to tell me that we can't do it. I find that ridiculous.
Yeah, no, I think it's big, and I like the vision of it. I definitely am rooting for this or something like this. We've been hearing about the potential for a long time. We did a podcast episode of Reversing Climate Change with Dr. Greg Dipple of University of British Columbia. God, it feels like a lifetime ago. But he was talking about waste rock being used for this from mine tailings. Is olivine a waste rock, or would it have to be mined specifically for this purpose?
Yeah, I just mentioned that. So it's sitting on the sidelines of mines already dug up. So it is actually, that will be hopefully where the first olivine and much of the olivine comes from. The question is it pure enough, etc. We also want to push the price of olivine down. So, for example, the cost for a 5,000 ton a day mine in the US, which is the highest labor costs around there, is only $7 per ton less. So that means the price of olivine, if you own the mine, is only $7 a ton, but the market price today is $25. So we're a nonprofit, so we're going to eat all that extra money in the inside and just get the price down as low as possible. And so part of that means having new mines started. To do the whole world, that 7 kilometers cube volume, we need about 30 to 50 mines. And some people will say there's not enough rock. There's a single mine in Bingham Canyon that is a copper mine. It has an excavated volume already, and it's continuing, of 25 kilometers cubed. So technically we can do it with one large mine. So don't tell me that the mines, we don't have enough rock. Don't tell me that it takes too long because you haven't weathered it on a desktop shaker and replaced the water and watched the grain on grain collisions. That's like the other criticism that people miss, is that you're not having the collisions, the water refreshed, and you're not having the animals that are using the carbonate and stuff like that. So those are the main criticisms, and I think they're bunk. And I think that what we're doing is we're going to prove it. But I invite all of you listening who have in your whole mind this whole time something, there's this reason, there's that reason. We are going to do this in an open source way. We've hired Deltaris, which is a engineering firm, open source in the Netherlands, who've done olivine in deltas and other places. And we're going to put the experiment up before we do it. Their recommendations, their paper, the studies they're doing, the way it's being done. If you want to make a criticism and try to stop this or have some input, you can do it at that point. If you sit there and stay silent until we do this experiment, and then you try to criticize the experiment, I don't know that I'm going to be so open to listening, because we're doing an experiment to prove it. So get involved in the science. It's open source. I want the haters. I want you on our side. I want you to tell me how we can make this better and how we can do it more efficiently and how we can save the frickin' planet. So we're all on the same side at the end of the day. And I'm pro tree planting. I'm pro plastic gathering. We need a war on all fronts to remove carbon, to remove pollutants, and to restore the planet. And that's what we're here to do at Project Vesta.
Well, I respect the open source ethos. I feel the same way. Well, what should we expect moving forward? What stage are you at right now, and what's coming in the next year or so?
So right now, we've just come out of stealth mode. We are recruiting. We have some scientists who've done olivine dissolution kinetic research already on our team. We want more. We want some of those haters to convert to lovers and to help direct their energy into making this project a reality. So hit us up, projectvesta.org. There's sections. We want all those criticisms and rebuttals to be discussed. We're going to throw up some forums, let you hash it out here, but we want to really see how we can make this happen. So the first step is getting a sample test beach nearby, somewhere where there's an olivine mine or tailings piles. And so the only requirements we have, you're out there and you have beaches or you have science abilities to run these studies and different things. It needs to be warm, humid tropics. The warmer it is, the more humid it is, and the greater the energy of the ocean in that area, and hopefully a shelf sea, the quicker the olivine will break down and the better our experimental numbers will be. And so that's our short-term goal. And then the next one is to go, we have a 4 to 5 phase plan. We may forego. Our early plan is to have a tank on the beach that just can tell us the weathering rate, but we're concerned that we're going to spend all this time and money, and then people are going to say, well, that's just a tank. It's not a full beach, and they're going to take away from us. So we may just jump right to a small test beach, and then we'll go regional, then we'll go country level, and we would have people like a Costa Rica who wants to offset, and they have 300 days of renewable energy, but they're responsible for 8 tons of CO2 just from cars on the island, which are not going electric anytime soon. So if you're Costa Rican and you're in the government, hit us up. We'll help you out. You got lots of coastlines. You're in the tropics. We're looking for these kind of synergistic effects there that where we can solve the problem by dumping our olivine there or bringing the olivine. And then there's regional ones. So there's an area near the UK where they do 4% of the world's CO2. The countries around the southern bight of the North Sea, we could dump 1.2 gigatons of olivine there. We don't even need beaches. We can do it right in the sea because there's enough bed shear forces, and we can offset 5% of the world's CO2 there. So we've got a regional one for you in Europe there. There's a whole paper on it. And then we also can go global, and that's the idea of having partnerships where countries with cheap labor and no good exports, they can start mining olivine, provide it to their neighbor on the coastline, and then we have a project that spans the boundaries of our planet because the climate spans boundaries, and we need to team up together to solve this global problem. And so that's kind of our vision, is to go incrementally up until the whole world, till we're getting that 7 kilometers cubed volume each year, and maybe even beyond, so that we can bring our CO2 levels back to 1850 pre-industrial levels, 280 parts per million, because today we're at 411 and it's not good.
Well, great. That sounds like there's a lot to do, especially if you're a hater. Hopefully you're a lover. A lot of worry about the haters, Eric. I think it's okay. I think you're talking to a friendly audience here. But that was Eric Matzner, co-founder of Project Vesta. You can find them at projectvesta.org. Eric, thank you so much for being here with us.
Great, Ross. Thank you so much for having us. And just a note on the haters is that the lovers, they speak much more quietly usually than the haters do. So I want the haters to know I know they're out there and I've heard what all of them say, and it's tired. Come up with something more creative, all right? Because we're going to do this, and I want your help, and I want the whole world's help, and we need to make it happen. So less hate, more love. Let's make this a reality.
All right, you heard it here first, haters. So I'm sure you have persuaded them to come check it out. And yeah, good criticism is very valuable to have. Having people give you praise feels good, but it's also more valuable for people to offer good constructive criticism. So if that's you, if you like digging into the technical details of stuff like this, Project Vesta would welcome your assistance. And thank you for listening.